Okay, welcome ladies and gentlemen to this video lecture. So now we will look at an example of how to apply what we call integration by parts. And remember, what is the idea here? The idea behind integration by parts is we want to compute the integral of the product of two functions, and we view one of the functions as a derivative, and we can transfer this derivative to the other function if we but keep track of it carefully. And perhaps in transferring that derivative to the other function, our integral that we are left with becomes simpler. So this term becomes simpler. And of course here in this term we don't need to worry about anything, because this is just substituting in the values of these endpoints. So by transferring the derivative, we are hoping to get this integral on the other side of our formula to be simpler. Okay, let's take a look at an example. Let's compute this integral. So we see here we've got the product of two functions. So we don't really have a product rule for derivatives. So the idea now is to apply integration by parts. So we will apply integration by parts. So now what do we want to do? We want to view one of these functions as a derivative and the other one as another function that we can transfer the derivative to. So our g will be the function that we view as a derivative, and our f will be a function that will hopefully become simpler if we take its derivative. So we see here we've got a 2x. So if we take the derivative of 2x, we just get a constant 2. So that is simpler. So we should guess that that should be our f and that should be our g prime. And let's see what happens. So let us define f of x as 2x and g prime of x as e to the x plus 1. Then f prime of x is equal to 2x, and g of x is equal to has to be equal to e to the x plus 1. Okay, so now we can just plug in these values for our functions that we have. So the integral from 0 to 1 of 2x e to the x plus 1 dx, that is the same now as integral from 0 to 1 of f of x g prime of x dx. We apply our integration by parts. So here we do integration by parts. What do we get? F of x g of x evaluated between the endpoints 0 and 1 minus the integral from 0 to 1, and now with the derivative transferred to the other function, f prime x g of x dx. Okay, and now we just substitute everything back and we see if we get something that is actually simpler. So here 2x e to the x plus 1 evaluated between 0 and 1 minus the integral from 0 to 1 f prime of x is just 2 e to the x plus 1 dx. And this turns out to be simple to evaluate. So this becomes 2x e to the x plus 1 on the endpoints 0 to 1 minus 2, this is e to the x plus 1, also evaluated on the between the endpoints 0 and 1. And if we do that, what do we get? Here we get 2 times 1 e to the 2 minus 2 times 0, that just falls away, minus 2 e to the 2 minus 2 times e. And that is what that looks like, and this looks like 2 to the e to me. And there we go. So here we see how we could evaluate this integral, which is the product of two functions, by seeing one of these products as a derivative and transferring the derivative to the other function, and then hoping that if we do that, that this term actually becomes simpler. And in this case, yes, it does. And this term becomes simpler, becomes an integral that we can actually evaluate. Okay, I will see you in the next one.